Okay, we are live and it's on time. That's a good sign. Hi,
Nice.
Lau. Welcome
Hello.
back.
Good to be back.
You haven't been here a while, but I'm super excited that you are today. And our topic also is interesting. We want to talk about self-driven code bases. And I think the plan for today would be we give an introduction what that means, but then also pretty much will be hands-on and show how we implement that new paradigm in our Fiberplane code base. And you mentioned before the stream that there's an interesting blog post everyone should know when it comes to this topic, right? So that the harness engineering blog post.
Yeah.
I can share my screen and also
go
post
for it.
it in the comment.
I think this is sort of everyone has been over January and February building there's like several names for this. Like the taxonomy is quite fast and loose, but it's anything from self-driving code base to software factory to background agents, and they have different levels of, they imply different levels of autonomy. So the terminology is fast and loose, but I think roughly it gives the idea is like, how do you set up a code base to maximize agent-driven development or agentic engineering in this? Which like very practically means how do you ship code with often async agents that once you've prompted them, they give you a long PR and they've implemented like larger features than something that you've driven in a peer environment, which means you have to steer them or set up the code base such that the code base can steer the agent as opposed to you telling it, no, you're doing the wrong thing. No, you're doing the wrong thing again. So it's a way for Codebase to reinforce those patterns itself.
So you want to go away, basically, that the human steers the full time so that the code base can take care of that, right? So, yeah. But the human would be still in the loop. So I guess ultimately the code base needs to be understandable for agents and for the humans. Am I correct here?
Yeah, I think the main thing is like this, like what you want to avoid, you can ship really fast with agents, but really quickly you will, if you are not careful, they will make the wrong choices, and those choices will quickly compound, and before you know it, you hit the complexity wall or something where you now have to do massive refactors, and what you thought you were shipping fast, you're not. So the idea is like, how do you reinforce those patterns such that you can go longer, either with a single agent loop or with many iterations, without fearing that like bad patterns snuck in or things like that.
And I think it becomes clearer once we also look into how we do that, kind of. Like, I think it always becomes clearer if you have a concept behind it. Yeah, should we talk a little bit how we do it?
Yeah. I can share. I'll share your nicely made slides.
No credits. It was Claude. Like, I mean, I prepared for
the thing is, you prompted them, so let's see. So I think the funny thing is like that nothing about this is quite new. All of these patterns around, which I would point to as explicit control flow as possible, so that you have all the different branches in which you can go, make them as explicit as possible, make observability as obvious as possible and as easy to see what's happening inside of your code. Lint heavily, have automated linting, and ensure your docs are up to date. So just to cover, like, we're mostly, I think, going to cover these parts, not the like, how do you set up a background agent? We don't yet have a background agent, but these are like, how do you make your code base and your app legible to the agent? I think that's a lot about what, for example, the harness engineering and a lot of these blog posts talk about. So the first thing we had is we've adopted, from starting FP, we've adopted effect, which is a more explicit, it's almost a whole language on top of TypeScript, in that like there's a lot of patterns that do feel a little odd if you've only worked in TypeScript and now you're seeing it there. There's like, I mean, you can start with like that all errors are results. Maybe I zoom in a little. Hold on.
Yeah. And you also shared, maybe I share that as well with the people, you shared a very nice Effect Institute tutorial. So if people want to have a hands-on experience what that looks like, or like understand a little bit more, I think that's a very great starting point. At least I looked into this today and I found that was very informative. Yeah. So I'm sharing this as well for everyone.
Yeah. Yeah, I think in full stack TypeScript, Effect is a great sort of platform to buy into in that, because there's a lot of explicit things that you get out of the box. There's explicit errors. That was the main thing for me. JavaScript, TypeScript has the throw and try catch patterns. And those are kind of like you have a parallel control flow, because your function can go from following an if statement, and if it throws, then it suddenly jumps to another place. And that kind of code where you're not reading things sequentially, you or the agent, ends up being quite hard to reason about. There's explicit dependencies. So if you construct your effect and a function that is an effect that does a thing, it has a format for dependency injections. So immediately in the signature of that function, you know what other things this function depends on, what other parts in the system this depends on. And also that pattern on dependency injections and services and layers is what makes architecturally your reasoning about in modules. Like it's a very modular and composable system that once you operate a level where your agent is producing 2,000 or 3,000 lines of code per PR, for example, I don't necessarily read, like it doesn't make sense to read line by line to try to understand it. You're kind of trying to understand it like, okay, what are the different modules in this system? What are the different moving parts? What are their inputs, outputs? And it just so happens that Effect has like really good ways of handling that.
Maybe because so you would say Effect is more agent friendly because it is more explicit, and that's easier for agents to reason about, or like to create the code. Question from my side is, what do you think if someone has never used Effect? How is the learning curve with it? Like I feel it's also a quite like it's a rather complex project. It has a lot of things in there, right? So how would you how was your own learning curve with Effect?
It's quite, if I had to write most of it by hand, it is a little unusual. But the curve, like there's a learning curve, but I would say these days, you can get to a working code with Effect more quickly. And I feel like, at least for me, that sort of reinforces how this thing works a little more easily. You can kind of hand off the because the slightly unusual patterns is that it uses generators. Like there's I don't know if this includes the example, but it uses yield, which is a syntax that many people have not even, I've not frankly seen it in a lot of places outside of it. It's just like all of your functions are now async generator functions. So there's like some pieces like that initially are like, there's a little bit of a hurdle, but honestly the payoff is worth it.
And I think we also did a trick here. Maybe we can tell the people, but I think we copied in a subtree in a git ignore folder into the project the Effect library, so the agent also could read directly the API and the Effect docs, but then not like get information from the training data or the internet, but rather read really the source. And I think that helped in our code base as well to have good implementation and effect in the first place, right?
Yeah, that's a good trick for any kind of library, but especially if it's so core to like how you're structuring it. It was nice to we didn't vendor it per se, but we just added it as a subtree so that an agent could look it up.
And one more question, Lau, because I think we also shortly touched it before we went live. Now, imagine we are a company and that has already a huge TypeScript base. Do you think it's worth to consider to refactor to effect to make it more agent friendly? And at times where we need to think of those self-driven code bases.
Yeah, I think it's worth it. Like you can add it incrementally. So we were lucky that we started it from the ground up, but you can add it to parts of your code base incrementally. So you don't have to sort of buy in wholesale and like pause development and everything else. You can do it so that like a new feature in your already existing TypeScript code base is adopted using effect. Yeah. Yeah, nice. I would say it's both feasible and I would pick it in any kind of next TypeScript project.
Nice, and I think you're already on the slide that also is very interesting, because I think I like that a lot, because although you decide for effect, still means maybe your AI agent is not using it correctly, although you might have set it up in rules and whatnot, but then it might still write this one line where it says throw new error, and that's something it should not. And I think the next thing that we've set up in the code base is exactly catching that syntax once it's compiled and checks it against what is in there. And I think that's also quite genius. So that's ast-grep here. Do you like to talk a little bit about how to set this up, and have we choose it from the beginning, or did we came to that after we saw that the agent is still like writing the wrong code that we don't want to have?
Yeah. This was actually sort of came about. So it's directly linked to the slide previously, or directly related to the fact that we've introduced ast-grep as a way to tackle this exact issue, which is we had Claude MD set up and all of that with like patterns that we want to see, things that we don't like. But the truth is that in a long running enough session, Claude or Codex or any of these agents will start to ignore your patterns. So the only way to do that is a just-in-time gate, basically. Either you do a reminder right when they complete or when they try to commit it, and then you sort of flag it. So this is like any kind of linter will do. We already used Biome, and I initially used Biome's custom linter plugins, but we've just found that ast-grep was a little more reliable with specifically syntax, and it's also works across languages, so you can have the same expression in that way. The next upgrade would probably be something like that is type-aware linting, but we'll get there. But it's a toolkit that Claude and Codex know how to use. So if you read the code in the initial phases, especially, if you find a pattern that you don't like, you immediately explicitly ban it by telling Claude to write an ast-grep rule to throw an error on it. And it's really, you have to throw an error. Like we've had warnings earlier, and warnings just get completely ignored. So you have to throw an error and basically not let Claude write a code that it would want to write. So we didn't want it to throw on errors. We didn't want it to. I mean, there's some like more aesthetic choices of like manually checking tags, but there's like some bigger ones that we found, which is like silent catching. Like it would have this habit of catching an error, not crashing the app, but then also just swallowing it. So that like is a pattern where I want these failure states to be logged. So then when I'm checking something, and if something doesn't happen, I can point Claude to the log output and be like, hey, is there something out there that you can find?
So the
and
process
that
then,
yeah.
The process with a code base is obviously if you write TypeScript, the type errors will be there, but that once those are checked, you still do the linting with, for example, Biome or any of those. And then the additional step here is that you would do an ast-grep check to see if your rules are compliant with the code that you've written, right? Yeah. And
ast-grep is a way to effectively enforce our taste on the code base. So where I'm looking to extending it further in how like modules should be structured, so that like certain functions, for example, the schema definition, we want it to be in a specific location. So if it tries to write a schema.struct in a file that is called, I don't know, utils.ts, which sometimes happens, that's immediately banned, and it's reminded in the error message that it should write them. It should write that in the right place, basically.
I do have a question. I don't know if you know it, maybe not, but like, do you know if ast-grep was a thing before we did the agentic coding? Like that library, I guess, existed before, but maybe it has now a deeper or a more use. What would you say?
Yeah, it's originally conceived as I mean, in general, this is conceived as a structural syntax operation tool, I guess. So this use case here is for scanning. So you define a pattern, you see that in the YAML file, and then it matches that pattern with the code. In other cases that you can use it, and we use it in our code bases for writing code mods. So if you have a lot of repetitive code that looks the same, you can write a script. It used to be really fun, but like you would only really do it if you had like a lot of, it's you're writing code that modifies other code. It's a little tricky. But I had to refactor a bunch of stuff in our code, and I already used a code mod script which used ast-grep. So it's a very it's a useful tool beyond the scanning. Like we use mostly for scanning, that's in our CI, but you can heavily use it outside of it. And because it operates on the syntax itself, it's not something that like white space things wouldn't get confused. It like reads the syntax tree structure of the language and modifies it at that level.
I think I read it uses tree sitter under the hood. That's correct, right? So for the syntax.
Yeah.
That's super nice. And I think then there is one more thing, and I think you are and I was wondering, did the ast-grep inspired you to do that with the docs? Was that an inspiration, or how did you started this project initially?
Yeah, so as in terms of solution, it definitely is like heavily inspired. I'm a big fan of ast-grep. I shill the tool on Twitter a lot, and in other places. Whenever people are like, "Oh, I don't know how to control my agent," it always writes the code that is like not how I like it. I was like, yeah, just use ast-grep. So I was inspired with it came from a different problem, which is we co-locate like similar to how the OpenAI harness engineering talk and a few others. We co-locate some of the docs inside of FP monorepo as a way to, like, frankly, that becomes one of the major ways that I read, for example, any new PRs that come in or any new information that is introduced, like that it's useful to have it there. It's, I mean, perpetual truth. It's useful to have docs, but the problem with them is that you need a maintenance on them as well. That's like another surface area to maintain. And unlike your types or any code that might be bound with type changes, so if one part changes, the other part yells that it's not, like the interfaces don't match. This is just plain text, and it, like, there's no way to kind of explicitly link it unless you're like maybe running an LLM pass on every PR. And so the idea is like, okay, the problem is that like, and I had that in my side projects as well, is like I write the initial pass and then I'm in the coding part, and then it makes some changes along the way, and then the docs are outdated.
And you even sometimes don't know at which part of the docs, because you don't know which, like, I mean, docs can be huge, so you don't know exactly which function you refer in which docs. And I guess this increases with the use of agents. And I'm glad that I just jumped straight into like, oh, have you been inspired by Tree Sitter? But it's good that you like that you told people again that the whole idea is that we also need to update docs and that we need to be aware when code changes. And sometimes I guess it's quite obvious which part of the docs might be or need an update if you change code, but sometimes it's also not. And I think it's a great tool for flagging those. Do you want to walk us a little bit how you set this up? Like, how is Drift detecting changes in the code base and matches that to the docs?
Yeah. So it's any markdown doc inside of your code base can be anchored. So anchor is a little piece of front matter that you can add, and it basically points to a certain file and optionally a specific symbol. So this is like an example from our internal sort of core library. There's a seed default extensions function that lives in cedar.ts file, and there are like what that anchor tells Drift is that this file has documentation that describes the reasoning or something about that depends on the code that is in here. And you can have multiple of these anchors in code. If then you can also optionally define like the last time this documentation was reviewed. So that's sort of referring to a specific commit. If there's no commit, then it just checks the last time the git blame essentially. But that's why this is a little more accurate. And once that's defined, Drift, anytime you run Drift, it parses the repo for all of the markdown files, extracts the front matter, and then for that, it just sort of has this like a triage, I guess, flow. It parses the relevant code with tree sitter as well. And it has like a hash normalized function. So it hashes that tree structure and it compares it with the state at which the document was stamped, you could say, anchored, versus the state that exists right now. And if these two pieces match, like it's all fine. We let it pass. You get an anchor okay, and it's fine. But if they don't, it exits on error code 1, and it says sign staled. I can actually, let's see if I can show you.
Is there a part where you then automatically can also update anchors? Or do you first needed to see in your docs, okay, I have like those 5 anchors in documentation and now I can update, but I probably would not update them manually, I assume.
So the idea, and this is something that I'm like still sort of in process, but so you can see I was debugging something because like this was not actually what I wanted to happen, but like I have piece of documentation. Let's see which one this is. Let's take the BS brainstorm. Brainstorm docs. Yes. So it has a bunch of anchors right here, as you can see, to like different parts in our backend. The thing that happened here was that I ran Drift, and those like this is how it sort of shows you at which point was when the code changed. So it's a little bit like git blame on the like, hey, somebody changed the code and hasn't updated the documentation. But this could as well be just your your own commit chain on a branch, where it's like it's effectively as like same as like ast-grep. It's a just in time reminder of like, hey, something has changed, and this part that should be changed as well hasn't been updated. And this is usually enough of a signal for Cloud Code or Codex to go and be like, oh yeah, right, I made some changes, and then go back to the part that changed the docs and update that part as well. It does reward hack, and I had it. So there's a drift skill. Let's see if I can pull up this. So there's a skill that comes. I think this might be an old version. I need to update it in the code base, but I had to play around with the. Let me share a different screen with the phrasing, so that the Claude Code or your sort of your coding agent knows how to work with drift. And so I had to add this like critical never relink without reviewing. So it can ostensibly just like run drift link again, and that anchor will be updated in place. But we don't want that. Like,
you want first a check, and then once it checks and it updates, then you can link to the new anchor point, I guess, right? So then that's fair.
Yeah. It's effectively like, it's a very dumb in some ways, just a blocker that like, yeah, this part of code is linked to that part, to that text file over there. And if this code changes, that text file needs to be reviewed again. That's like the full loop, essentially.
Nice. And I think, yeah, I mean, you mentioned already, I think it could be internal docs, but it could be also external facing docs. I guess it makes sense for both to have that.
Yeah, I have drift on. So yeah, this is the drift repo. I have drift set up in the README. I had it. Oh yeah, it's there. No, that's an example. Well, I need to update that. But one of the common things is like the README gets out of date. So you can add a drift anchor with a commented out HTML sort of style, and the drift parser will still pick those up.
Nice.
So in case your code changes and your README needs to be reflect the change, that's like another sort of a flash. So or your skill, for example. Yeah, this skill, for example, has a drift.
But you can use the HTML uncommented tag if you don't want to have a front matter, or how do you?
Yeah, so you can add it. So was specifically for READMEs. This skill, if you look at it, the rendered view has now drift front matter. And if this is your README, which is often the landing page of your project, you might not necessarily like that. So you can just put it in a comment, and it won't be visible in the renderer, but the drift linter will catch that.
I mean, that makes sense. Nice. Is there like, I mean, we talked a lot about our code base. We talked about effect for TypeScript for agents. We talked about ast-grep, and now we talked about the update of documentation towards a self-driven code base. Do you think there are some parts that we shouldn't or should talk about that we haven't yet?
I mean, there's like integration testing, fuzz testing. There's I think over 20 or 30 year culture on effectively running large code bases that we could probably each parts we could cover. I think the interesting part with this is like these used to be exercises that you do once you've reached 100 people on your team, and the overhead of communicating patterns and stuff outside of the code base becomes so heavy, and the onboarding of a newcomer is like so long that you enforce these patterns in there. Like usually you would start and just whip up code quickly, validate the idea, and only then really start thinking about how these things should sort of should play together. But like, it's an interesting dance because like you're not probably gonna start with like a fully distributed system like early on, but there's a lot of value in setting up good scaffolds from the start, so then you can more confidently just prompt the agents and be like confident that like, one, this code will either work, or if it doesn't work, then the agent has like a very quick way of fixing it.
Yeah, so basically, even smaller teams now need to consider this because the speed and way of shipping gets faster with those agents. I'm wondering, I mean, I feel we are still in a territory where things, or where every organization needs to figure out how to work with those tools. Would be also interesting to understand how larger organizations probably deal with that. I think they probably have different challenges, I could see. But maybe also some of the things they have already in place. Who knows in the end, right? But yeah, that's probably also a different topic if you have and work with an existing code base in a large organization. Yeah, I don't know. I think that was, for me, quite insightful. I now have a better understanding how and why we decided to set things up the way we do. That was insightful. Is there anything else we should touch or mention?
No, but we should talk about fuzz testing or observability next time.
Yeah, I think that's a great topic. And I also shared, by the way, the blog post to your Drift documentation linter. So I feel if people want to try it out, and also they find you directly on Twitter and on the socials. So if there is feedback, probably you are the right person to contact.
Hit me up on Twitter or Blue Sky or wherever. And also, Drift is open source. So if you have comments, feature requests, feel free to drop them there.
Nice. And with that, I will press our end the stream button.